to the Using VBA for Excel and the XDK to Improve the At-Risk Experience webcast. It's quite a mouthful, but what we're going to look at today is utilizing VBA for Excel code with at-risk's built-in XDK to enable you to do things easily in Excel. Some things that are a bit of a hassle to perhaps do, much as you would already or ordinarily use VBA for Excel code to make your life a little bit easier. But there are a few specific things in at-risk that the XDK or the use of VBA code makes some specific aspects of modeling in the general work environments in which we exist much easier to handle. So let's get started. Now the first thing to note is that this is not a webcast in VBA for Excel. It is presumed that you understand something of that language or are able to produce simple macros and follow the idea of a VBA code, getting a macro to execute and so forth. What I will be looking at instead are the options specific to at-risk's XDK and some ideas for when such an application might be most appropriate for you and your organization. So initially, we have in front of us an at-risk spreadsheet. Now, just as we have example files, as I've used in previous webcasts, I'm sure you've all looked at before, example files to help explain different concepts about the software, we also have a specific set of example files for the XDK. Now, the first thing to note is that if you have at-risk standard, then you are not able to utilize the XDK. You need at least the professional edition to do that, so professional or industrial. And if you do, you will see that you have various references to help you get going and to build very cool XDK models. Now, because of recent improvements to the XDK, it now has its own reference section. There are videos on our website specific to the use of the XDK. There are our own specific examples and a lot more examples of using the XDK than the software previously was installed with, as well as automation and reference guides for doing XDK work yourself. So, as I said, if you already know how to use VBA for Excel, you basically already know how to use the XDK, but it's worth finding out what elements are actually in the XDK, what are the sorts of things that you can do. And if you're not an expert in VBA for Excel, don't worry, I'm not myself, but I have been able to use the XDK in the past because it is very simple. In fact, VBA for Excel code is fairly straightforward, and I've definitely been able to make my life and my clients' lives easier by using VBA code. So I'll open up some examples, and let's get an idea of the sorts of things that we can do with VBA for Excel. Now, a very common thing to do with VBA is things that you want to do over and over again, but you'd just like to click one button to get them done. Pardon me. And that particular usage is no different for or when you're using it with at-risk. There might be lots of things that you would like to create, such as graphs. And rather than creating each of them one at a time, we may have a model here. For example, this is a simple pardon me, cost model where we have 5 outputs. We would like to perhaps generate charts, as you can see are going to fill up these spots, run a simulation and generate multiple charts, all by clicking one button. So I'm going to click the macro button and let's see what happens. You can see that the only thing I've actually initiated is the clicking of this macro button itself. A simulation has run, and now in the background it is creating my charts and results. All of these graphs for simulation 1, 2, and 3 have been created automatically. So there are 12 charts that were generated. Input graphs, output graphs. We can see that the graphs have all been named. So we've got an overlay in there. pardon me, across 3 different simulation runs. Now, how does at-risk do this? Obviously, there is a VBA for Excel code in the background that has performed all of those tasks. So let's start by having a little look at, under the hood at the sort of thing that this code will look like. So I go to the VBA editor, and I see here we have our macro called create graphs. Looks like standard VBA for Excel coding so far. We have a few, pardon me, defined variables. We have a for next loop. We have a with loop here. But what we want to specifically look at are some at-risk or some at-risk functionality and coding. For starters, we have a with loop with risk.simulation. It's quite clear exactly what is going to happen now. I have risk.simulation settings, start the simulation. I can also have results and so on. So inside the with risk.simulation loop, I've got a with.settings, num iterations equals n iterations. So the code all looks very familiar in terms of VBA coding. But we can see straight away that these various aspects of a simulation, and so in particular here, a simulation setting, can be run or can be generated. So I have, for example, the random number generator to be used, a specific random seed, sampling type, and so forth. Show the recalculations, yes or no, enabling smart sensitivity analysis, that type of thing. And so you can see that the IntelliSense option, which makes VBA for Excel very easy to use, is also available here when I'm writing code with at risk. We in fact have a video on using IntelliSense just to help get you started in writing the coding. Obviously there are many different objects and methods available within at risk, and IntelliSense makes it much easier to type these things in. So I have my different risk simulation settings, as we see here. We are creating graphs with our results.graph distribution for an input, or results.graph distribution for an output. Pardon me. And then these are being placed on a particular worksheet in a particular location. So we have a lot of control over where these graphs go. Now, pardon me. So I go back to my example. It may be the case that you are familiar with the risk results graph function. These different charts here could all be generated using a risk results graph function. Now what would that require? It of course requires a function to go onto the spreadsheet. That function needs to have a bit of a particular place. It needs to have been inputted where it needs to go. There needs to be correct cell referencing and so on. Essentially, a user is needed to place these volatile at-risk functions directly on the spreadsheet, and then the results are run. Now, one of the very common uses of the XDK and VBA for Excel code with at-risk is to take away that functionality. Now, you saw previously when I went to these 3 sheets, they were completely blank. There is no functions there. There is nothing for a user to delete, be it accidentally or intentionally. There's no way they can ruin where you're going to place these things because it's built into the code. Also, instead of asking a user to understand the simulation settings, to know what number of iterations to use, simulations to be run, what do these options mean, what do these options mean, what do these options mean, and so forth, we can consider these needs prior to creating the model. We can build those into the coding and then take all of this at-risk optional functionality out of the user's hands. They do not need to know how this ribbon works. They just need to be able to click this macro button. So a very common workflow is to build the underlying model to begin with, work out what results you want to go where, how the model will look, where the inputs and outputs are, and so on. And then codify all of those things behind macro buttons. I've also seen clients successfully use multiple macro buttons for different needs, where each of the buttons had in it a simple to read and understand a set of instructions about what should be done. In my mind, the example I have is run a short simulation or quick simulation, and then run more comprehensive simulation and create reports. So if the user simply wanted to run a quick simulation, maybe get a chart, check a few of the statistics that were coming out to make sure it seemed reasonable, there was a quick sim button. Then the more comprehensive simulation button ran a larger simulation and also produced various specified reports. So you see, it's not just a matter of doing a whole bunch of things in one go by setting it up in code, and then every time you click the macro button you're saving yourself time because you're not creating these things over and over again. It's also, especially in a larger organization, useful to take some of the guesswork, if you like, or some of the knowledge, or indeed potentially dangerous power, out of the hands of a user and simply explain via macro buttons, click this first, then click that, then click that. So I'll put that example away. Pardon me. Now, in our example files themselves, there are some examples just to help you get started. So as I said, for those people who know what they're looking at, they just need to understand a few more of the options. Things like our object model diagram example gives you an understanding of the different bits and pieces that go into typical XDK code. So we've got an example of some typical code there, things you might want to do in a simulation, application settings, simulation settings, results, graphs, reports, looking into the model itself, distribution fitting, data filters, goal seek, advanced sensitivity, stress analysis, and the integration with MS Project. Now we'll look at several of these examples today, but as you can see, it's quite comprehensive, the amount of assistance that is available to you here, where you can basically teach yourself how to use XDK, especially if you're already familiar in some manner with VBA for Excel. Let's look at a few pardon me, more simple examples. So let's look at some simulation basics. What I have here is an example model where it's a simple MPV model. Again, I have a single run simulation button, so I'm potentially interested to know what that's going to do. Rather than run the macro first, this time I'll actually have a look at what the macro itself is doing. So I have some variables here. I have the, pardon me, the capacity to delete the graphs from my active sheet because I've written a sub to do so. Here's one of the cases where at-risk makes it easy for you to do things. So for example, the phrase picture is in every at-risk graph. So you can easily delete your old graphs and replace them with new ones by stealing this code. For those of you who are familiar with VBA for Excel code, just to let everyone else in on a secret, most coding is actually done by butchering other people's codes. So we go online, we check previous example files, things that are similar to what we want, we take that code and then we adapt it to our needs. So one reason to have so many different examples is to enable you, both for general at-risk and also for Risk Optimizer, is to enable you to get started in your own code. You might want to run a different number of iterations, different number of simulations. Perhaps you do want results to automatically display, so instead you would change the settings here. We see that we can control, as I mentioned before, exactly where charts are placed. And another example of things that are possible using VBA for Excel that isn't part of the regular at-risk functionality. Obviously, in general, the idea of clicking a macro button and doing several things at once isn't something that at-risk is designed to do. Also, the statistics functions that are created by at-risk generally all need to be functions directly on the spreadsheet itself, much like the risk results graph function we saw before. I'll show you some potential problems with the risk results functions and the way here that at-risk is able to overcome that issue. So I go back to my model and I'll run my simulation. Again, we see simulations being run in the background, and here we have some results being pasted into a standard message box that Excel creates that's commonly used to look at results from a macro. So we have various statistics for simulations 1, 2, and 3 as they come up. Simulation 3. Now what I want you to note is that results from simulations are able to be placed into something like a message box. This means that simulation statistics can be automatically placed into the spreadsheet via the XDK without you requiring to have that function on the spreadsheet. And just for fun, there was also a few graphs that got put in at the very end there. Oops, sorry. Let's quickly go and have a look at that one. We can see that there is indeed graph placement, results with .results.graph distribution for the MPV for a particular simulation number, 1, 2, or 3. It has a description where our rate variable is used as part of the label. So we know that our discount rates were 5, 10, and 15% across the 3 simulations. And then after each graph has been put into the spreadsheet, then the next one gets shifted across. But if I put that away, I'll show you one where the simulation results themselves are placed directly into the spreadsheet. So here I see that I have space made for some statistics that come out of this profit model. Obviously it's a very simple model, that's not the defining feature or issue here. The issue is the actual pardon me, macro code itself. Now what this one will do is run its simulation and create the results that previously we'd seen in the message box, and this time put them directly in the spreadsheet. So once again, there were no functions there. There was nothing in at-risk that could be deleted or changed. Everything was codified and hidden, if you like, inside the VBA for Excel code itself. Now, this method for creating results has some big advantages over the standard method for producing this type of figure. So if I want to create the mean manually, I'll use a risk mean function, ask for the mean of the profit, say, and I will of course get the same result as before. And perhaps I will also generate the probability of loss, which in this case could simply equal the mean of this cell, 5%. You'll see there's a touch over a 5% chance of the results being less than 0. So these two results of themselves make sense. And I'll just format that. But they are both at-risk functions. So every time I run a simulation, they'll be different. That's okay. They are functions that could potentially be edited unknowingly, such as different percentiles could be changed. There could be concerns about which output I'm looking at, and so on, these sorts of building block stuff. But there are some subtle, much trickier concerns that often do fool people. So if, for example, there is no simulation data in the file to begin with, my functions, the ones that I've hard-coded in here, return whatever value they currently see, or a result based on the value they currently see. There are no results. So the subtle problem that people often encounter is opening a spreadsheet, looking for a results table, seeing that there is at-risk functionality within here, and presuming that these are the answers. If I put in another, say, 90th percentile, we'll go in here, so we know it's going to be a risk percentile function, looking at the profit, and just cheat by hard coding 0.9. The 90th percentile is given as 20,000. Now we know that's not true. We know the number probably exceeds 30,000. However, because there are no simulation results, this table is producing nonsense numbers. Okay? And in fact, if I were to look at random sampling, and this is my viewing option, whenever that value is resampled, I will actually get different results here, because once again, these statistics functions look at whatever is available. There are no simulation results per se, so it's looking directly at this information here. So with the profit being positive, there is of course zero probability of loss. Now it would be of some concern if these results were being read, especially now when I'm apparently claiming there is a 100% chance of loss. So the functionality that at-risk has on the spreadsheet for producing these results, they do exactly what they claim on the box. Absolutely no problem there. However, our personal interpretation may not be completely appropriate. So an alternative to having these things in here is to utilize VBA for Excel code, whereby there is in fact nothing there. There are no functions to confuse you. There's never going to be a value in here which does not actually make sense for what it is compared to the standard functionality. So if I run the simulation again, we'll see this has been repopulated, but these values here will either be the values that they are, as in these are actual hard-coded raw Excel values, not linked to anything. They will not change. I can open and close the spreadsheet as many times as I like. I do not need to store the simulation data. This is a fixed table of results. And if I do delete them, I run the simulation again, they'll be put back in. I do not have to remember the appropriate formulation and so on for these functions. I don't have to worry about people misinterpreting what they are if there isn't simulation data. And potentially, because these are all created using the simulation, I don't even need to worry about whether or not these results come from a decent simulation run, because the only thing that gets the numbers into here is the simulation that I have defined in here with potentially an adequate number of iterations and so forth. So although obviously the applications for these things are completely limitless, hopefully you're getting a feel for the types of things that you might want to use these things for, use the XDK for. So if we look at, pardon me, some more examples, let's look at a filter creation macro. Filtering is something that can be very, very useful and provide some great analysis of your simulation data, and it refers to literally filtering out different values or different iterations potentially from your simulation, either whole iterations or just individual values out of an input or an output. Pardon me. So if I click this, it has run simulation with and without filters. Let's see what it produces, and then we'll go and look at the code and see what it was actually doing in the background. So here we have three charts that have been generated first. The MPV with no filter. Now I have the MPV where there are only negative values. And we can see here that there have been 4,594 filtered values. So 406 left. They are all the losses, and now my chart and my statistics are for the losses only. I have the central 50% of values. Pardon me. I have filters on the inputs. This is filtering the output. Now I have filters on the inputs, where the year one costs are above the median and the year one revenues are below the median. And we can see, obviously, we have a much bigger probability of loss than before. And we also have a lower capacity to have higher revenues. Absolutely makes sense logically. And of the 1,260 values remaining, where year one cost is above its P50 and the year one revenue is below its P50, this is the distribution of the output. Pardon me. Here is the cost distribution itself. So that's input, just values above the median, or the revenue distribution for year one just below the median. So this sort of filtered information could indeed be very helpful to you. And once again, it's the type of thing that can be done using the filter option in at risk, but involves or requires a user to be skilled or knowledgeable in that particular aspect of at risk. It can often be better to set it up for the user, so they only need to either change nothing or make very minimal changes to the model itself. Now, because we're looking at VBA for Excel code here, all of the values that I have hard-coded into my chart, such as putting in a filter between the 25th and 75th percentile, and therefore producing a chart showing only the middle 50%, these hard-coded values could themselves be variables. A user could type those values into the spreadsheet or even into a pop-up, a non-Excel looking interface, so pardon me, a little text box or drop box pops up, combo box, where the user can then simply click, like point and click interface style, click in, change either with a drop down or type in the percentiles they wish to see as the highest and lowest. And those values will be referenced here and therefore create the chart specific to the user's need. But all they need to know is this. They don't need to know how to do that filtering in or with at risk, which of course it can do. If I grab my results here and check out the filters, I can see that I can change filtration type and what is filtered. Going through this dialogue is certainly a useful skill, but maybe not one that you want all of your users to have to spend the time learning. So instead you just say, here's the lowest percentile, here's the highest, fill in those values somewhere on the spreadsheet, and my code will go and read them for you. Pardon me. So all the different filtering options for those charts have been included in here. And thus producing these results. So again, quite straightforward in terms of how to do it. Simply with dot filters. Now we have a with dot results loop, graph distribution, filters, apply changes, get me a chart, give it that title. So the risk standard filter, risk negative infinity to 0. So from as low as you want up to the number 0. That's obviously this chart, and then apply that filter and so on. So clear the filter, make that change, and then put a new filter on and create a new chart. So I could do this once in VBA for Excel code, and then every time I go to run my simulation, I get all 6 of these charts. Or I would have to go in 6 times into my results, apply the appropriate filter, build the chart, paste it in, change the filter, build the chart, paste it in, do that 6 times, and then do that 6 times every single time I want to produce this, or simply build it once into the VBA for Excel code. It's pretty clear which one's going to be the most efficient method for you. Pardon me. Now, another common use of VBA for Excel code is to do things with data, and potentially with data from other sources. So here I have some code that will, pardon me, for a particular query on a database, which I can include here, such as my step ladders. I want to go and get information on that. Click the macro and see what comes up. So I've actually gone and got data. I've then done a distribution fit to my data set, place those results in for my demand for step ladders, and I can now produce a simulation and results for that. So there is my demand for step ladders. If I choose a different product, let's look at hammers. Okay. What's my hammer data look like? Well, it looks different. So the distribution fitting is now being done, and I have a different risk Poisson distribution representing the demand for hammers. Now, what is it doing here? It's not just sticking to Excel. VBA code can be written for all of the Office products, of course. So if I look in here, we see that I am importing data from an Access database with the query that was defined on the spreadsheet. Okay, so this sort of querying and getting information, that's standard VBA for Excel stuff. The twist that we've added here is to then do or perform an at-risk analysis on that particular data set. In this case, at-risk is being fitted. Clearing the old fit, creating a new fit distribution, performing the fit, fitting or choosing the best fit based on a particular test, accepting that result, then it runs a simulation, gets some more results, pardon me, getting, I think there's some charts in there perhaps as well, oh, there's some statistics, sorry. And just as we saw before, putting statistics in for min, mean, max, standard deviation, P5, P95 of the total in lost demand and total in revenue, or my total revenue distributions. Okay. So all of that could be pre-programmed in for yourself or for a user, whereby all you have to do is select the product you want, click the Go button, and a whole bunch of things happen for you in the background. The alternative is to just have code, or maybe even no code, just go and get it manually, get this data. Then what you would need to do is understand what it means to fit a distribution to this. You would need to understand what type of data you're looking at, which distributions you wish to choose, what information you have about the limitations, so not limitations, about the limits themselves, my mistake. And then when you get a fit result, understand what the different fit rankings are and which one's most appropriate to you, and so forth. Or, instead of all of that, make those decisions beforehand or have experts make those decisions for you, and then all you need to do is go hammer, drill, shovel. Let's look at shovels. So the shovel data is being selected, placed into the data set, a fit is being run, a simulation is being run. These results have been updated for shovels, and I can see my shovel data is now in the background. Okay, so very common application of, or the usage of VBA for Excel, but then with an at-risk twist. We can see in our example files, there are various data fitting, options. Got bootstrapping, basic fitting of a distribution. We've got batch fitting in here. So if you're doing some things with data like that, it's probably a good idea for you to look at one or more of those examples to get an idea of how the software might work for you. Pardon me. We also have pardon me, the advanced analyses in at-risk, goal-seek, stress analysis, advanced sensitivity. Again, each of these has their own dialogue, which is fairly straightforward to use. But once again, as always, you might want to do something similar every time and you don't want to go through the dialogue to set it up. Or you'd like to be able to set up someone who maybe isn't as familiar with these options and enable them to produce particular analyses every time. Let's look at, say, a goal seek, which is one of my favorite advanced analyses. Now there is some sort of goal seeking in here. I'm going to click Run Goal Seek and let's find out what it was looking for. The cost factor that makes the 25th percentile of the MPV equal to 800 is 0.762. Okay, so I've been able to click Go. I get a message box appearing telling me the answer that I'm interested in. I did not need to know how to go through the goal seek dialog, set this up, set up the various options, and so forth. I didn't need to know what the options should be for iterations and so forth. It was all just done for me. Now, like everything else in VBA Excel, it's basically quite straightforward. Run goal seek, risk.simulation.new goal seek analysis. It's all quite straightforward. It's just a matter of finding out what these bits are to have them as your options. Targets, pardon me, how many iterations for the goal seek, check if something's not found, put in a message box, and there are our solutions, what's the statistic we're looking at, and so forth. So now, again, as a user, the only thing I really need to do is run the model. Potentially, I will input different values here that represent a particular model, but otherwise this could be a template upon which the goal seeking can be run. And as always, these hard-coded values could themselves be either values on the spreadsheet that a user can enter, or values in a combo box, or some other pop-up that a user could select. Take that goal seek one away. Looking at another goal seek example here. As I said, we can make things fairly simple. Choose a summary measure of MPV. So I have here some radio buttons to enable me to pick which statistic of the MPV I'm interested in analyzing, what value I want that to get to. So if we stick to the default, which was to get a mean of this MPV to 1,000, let's see what needs to be done. So I've got a neat little radio button color-coded solution. I see that the cost factor is gone from 1 to 0.937, and I have a little message here letting me know nothing's wrong, but a bigger simulation will now be run for this new value that GoalSeek found. And not just a simulation is run, but a chart's been created. I can put that away. And one thing I do want to mention about charts before we go, I'll show you a few other little bits and pieces, but the risk.graph object now exists. We've seen various charts be created that all look fairly familiar. The sorts of charts that we could create using risk results graph functions. However, the neatest, if you like, charts or the best charts that we can create using at risk, and I'll just grab a very simple model here to run a simulation risk. The best charts that we can create with the most options that we can play with is by building a chart, right-click, graph options, and actually playing in here, changing things like the curves. Now, using a risk results graph function, you cannot do things such as change the color to, let's say, a bold orange, and change the style to a solid with a spline fit interpolation. This couldn't be done with a risk results graph function. However, with a risk graph object, we can change these things. I'm a big fan of removing the shading outside the delimiters, so I would do that. Now, I might make 5, 10, 20 different changes to this chart. I've only made a couple so far. I might get rid of my x-axis, include some markers. And maybe now I'm done. I could make other changes to font and so forth. Perhaps it takes me 5 minutes, 10 minutes to make these changes. Maybe I can't remember all of the ones I want to make and so on. But to get this graph, I used to have to go through this dialog. This was my only option. And then from this chart, I could copy it, I could save it, I could put it into Excel and so forth. But all of those changes I made can actually be edited or generated, if you like, using the risk graph object in VBA in the VBA coding. Put that example file away. So if you have a look through some of these graphs and reporting examples, none of them produce very fancy graphs, but they can be edited to do so. So it's graphing a distribution, but I can make various changes to the graph itself. So definitely have a look at creating very fancy graphs using the XDK code. The result can either be a graph that is produced pardon me, and simply sits on your spreadsheet like the browse results option. You can also create a graph that has then been copied, and you can go anywhere in Office and press Control-Z, and your fancy graph will now be pasted in. Again, I said something that is worth exploring. Put that away. Just a couple of more things to show you as our time starts to run down here. We'll look at a project example. So this code here, at the moment I have an empty workbook, essentially. What is going to happen? A file will be imported, parameter entry table created for the task durations, simulation run, and a probabilistic Gantt chart created. So import a project and run that simulation. This might be a standard sort of analysis that I would like to run. So rather than actually doing it every time, I can write VBA code to perform the task for me. And of course, while I'm waiting for this to run, standard ideas like human error is, of course, the biggest cause of problems with computers. Not the software, not the hardware, actual people clicking the wrong thing. So if I've codified things like number of iterations or import options and so on, well, I can't get that wrong. I have to go out of my way to go to the code to change it to cause myself problems. So I get it done, I get it run once, I get it fixed, I get it set up such that if there are errors or mistakes, I can get error messages to pop up to let me know that these are problems. So so far we're nearing the end of our simulation. So the MPP file was imported, pardon me. The parameter entry table was created. It's been had some data included in it. The simulation's been run, and as the I love these pop-ups, it has been successfully run, which is good to know. And I have here in a brand new workbook the probabilistic Gantt chart as a result, where I can compare my static or deterministic schedule and its start and finish dates with what is likely to occur. And so if I look at this as a database training project, the very last task is group 4 training. On average, this will start after my deterministic schedule said it was due to be completed. That's some useful information. Pardon me. This new book was also created that actually has the model in it. Information about resources and so on was also included, and this information was included. And that's been taken out of my, pardon me, PowerPoint, oh not PowerPoint, sorry, project schedule that's in the background. Put that away. And then I still have this importation here. Just a very quick look at that, pardon me, at that coding. We have risk.project.import MPP file. Goes into this workbook, that path. Add a parameter entry table of a certain type, plus or minus percentage changes from the base values. Very common way of approaching project schedule uncertainty. There's a simulation to run, and so forth. Risk.project.create probabilistic Gantt chart. See how things are very straightforward for you. So it won't take you very long at all, especially if you understand how VBA code works, for you to be able to explore and understand how to create the things that you want. Risk.project. Here are my options. Critical indices, create a standard Gantt chart, import a file, simulate a date range, what type of engine to use, sync the project, and so on. Obviously that's not a valid piece of code, so I'll get rid of that. So as I keep saying, it really is quite easy to teach yourself how to use this. One last example using some color and movement is including results in a PowerPoint presentation. Here is a model where, pardon me, I have my model like this. It's not too pretty, but I'm going to get some results and have those results placed fresh into a PowerPoint document or PowerPoint file. So I go to my model, I run this app. I have a portfolio of investments there, only the two. They're correlated. I'm going to generate results about my overall year one return, the 2-year return. You can see the PowerPoint's been opened here. Now let's have a look at the different charts that have been, that I've, if you like, decided to create and place them into a PowerPoint presentation. So if I go to the top, go title, standard S-curve for year one, descending S-curve for year two, or the 2-year portfolio I should say, overlay of those two densities, some sensitivity analysis for the year two, scatter plot, overlay scatter plot, and you get another scatter plot looking at different types of returns. Okay, so there's my PowerPoint slides, run and done. So whenever I know that I need to produce something for an upcoming board meeting or something, here is my model. My app will create, after running a simulation, create results and put them into a PowerPoint file. Okay, nice and neat, straightforward. So as you can see here, most of these examples, or all of these examples, are quite simple and straightforward. The code is there for you to butcher and use as you see fit. Pardon me. The examples are a very good start. We can see there are various examples there. There are also XDK examples using Risk Optimizer. And if you explore the rest of our tools, you'll see that most of our Decision Tools suite has an XDK styled, or EDK, different names to it, a way of combining VBA for Excel code to make your life simpler, to do things far easier. An example I mentioned in a recent webcast was I created, just for fun, an evolver model that had 10,000 pardon me, 10,000 constraints. I obviously was not going to use the interface to do 10,000 constraints, but it took a fraction of a second building those 10,000 using the VBA for Excel coding. So these same benefits to using XDK are also available to you in the other products as well, or most of the other products as well. Okay, definitely worth having a look at. And just a reminder, in terms of looking at things, the XDK does have its own help section, including the videos, which are of a great help to get you started, showing you how to use IntelliSense, some basics for what the object model is. Pardon me. We have a reference guide, automation guide. There are a few things you need to set up in your pardon me, inside your VBA to make sure it will work. We need to reference the tools appropriately and so on. Otherwise, of course, the coding won't work. It needs to reference the at-risk library, that type of thing. But it's all explained inside the help files, so you can get started straight away. All of those settings have already been put into these example files, of course, so they're ready to run as soon as you launch the software, and off they go. So I hope that's been of some interest and or help to you. As always, if you do have any questions or follow-ups you'd like to ask or discuss with us, please just contact our office. Otherwise, I will see you all again, hopefully, in a couple of weeks when we continue our optimization webcast, looking at part 3, which is Risk Optimizer. And if we have some time during that, I might also run some VBA for Excel code in that Risk Optimizer webcast as well. Otherwise, enjoy your day. I hope you've gotten something out of this webcast and that we will see you all soon. Thank you.